Hello everyone, welcome back. For today's video tutorial, I will be introducing a new sensor that is TCS34903. And to have a better perspective regarding the sensor, let's visit the website that is controleverything.com, and here we have to search for this sensor and let's see what we got for this sensor. And it's a color light to digital sensor, as you can see, and these are some of its more features described here. Also, you can purchase the sensor from this website. Now for the interfacing part, as you can see, I will be interfacing in this video the color sensor TCS34903 with the Raspberry Pi and a Python code, and go to resource tab to get the Python code. As you can see, you can download the Python code sample as a zip file from here. Also, you can have the code from github.com, and the repository there is Control Everything Community. Now what do we require is to have a look over the hardware connections we need to set up, and let's see and proceed further. In the hardware section part, first of all, the requirement is our color sensor, that is TCS34903, and this here is a Raspberry Pi, and these are the GPR pins of the Raspberry Pi. Now this here is an I2C Shield, and it's available on the website controleverything.com. The reason we are using this I2C Shield here is to make easy connections with other I2C devices, and for that, gently place the I2C Shield over the GPR pins of the Raspberry Pi, and then we are done with this connection. Now this here is a connecting cable, and make the connection of the cable and the sensor, and make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and same for the I2C Shield. Next, we require a micro USB cable just like that to power up our Raspberry Pi and gently insert it over the power jack. The last part is to provide internet connection, and for that there are two ways, and first way is an Ethernet or LAN cable, as you can see, and gently insert it over the Ethernet jack. Next, we require a wireless nano USB adapter in case if we don't have the LAN cable or the Ethernet cable, and it might save your day also. So we are done with all the connections we need for this setup. Now what do we require is to look over the code so that we can interface this with our sensor. Now for the interfacing part of the Python code, we have to search it on github.com, and here login github.com, and here we have to first of all search for the repository that is Control Everything Community, and after that we have to search for the sensor that is TCS34903, and it's a color sensor, and this here is a Python code. Let's have a look over the instructions. First, for the Python code, as you can see, we have to download and install SMBus library on the Raspberry Pi, and this link will help us to install the SMBus stepwise steps. As you can see, examples, dependencies, commands, everything is there. Please note down that carefully and do the installation. And this here is the command to run the Python code. Note it down also. And then get back to the Python code, and it's a .py extension file. Now, as you notice in the code, we have imported SMBus and time libraries, and we have the address of the sensor that is 0x39. Now in the working part where we are sending some commands, we are selecting enable register having address 0x80, and we are sending 0x03, which goes for power on, RGBC enable, RGBC interrupt mask not asserted, wait disable, sleep after interrupt not asserted, and the writing command is here. After that, we are selecting first of all RGBC integration time register having address 0x81, and we are sending 0x00, which comprises for A time, that is 712 ms and 256 cycles. The writing command is here. Then we are selecting the wait time register having address 0x82, and here we are sending the command that is 0xff, which goes for W time, that is 2.78 millisecond, and the writing command is here. After that, again we are selecting the RGBC gain control register having address 0x8f, and 0x00 is the command we are sending for A gain, that is 1x, and the writing command is here. In the last writing part, we are selecting IR register first, that is 0x30, and 0x80 is the command that we are sending to enable IR channel, that the writing command is here. What do we require next is to read the data back from the sensor, and we are reading data back from the register that is 0x94. It's the clear or IR infrared channel, As you can see, 2 bytes are reading, and after that the conversion of the data takes place here, which is according to the guidelines provided in the data sheet for TCS34903. And then again we are reading data from the sensor and the address of the register, that is 0x96. A red channel is here and the conversion of the red channel takes place here. Then reading of the data from the register 98 takes place, 0x98. And it's the green channel and the conversion of the green channel data takes place here. And the last in the reading part, we are reading, as you can see, data from the 9A register 0x9A, and blue channel is there and the blue channel data converts here. In the conversion part, we are calculating luminance, ambient light luminance, and the formula is being provided in the data sheet also. Now at the very end of our code, we want to display the results on the screen and output data. As you can see, we are printing, and it's infrared, red color, green color, blue color, and ambient light luminance, and the unit is lux. Now what we require is to have a look over the practicality of this code, and let's see how it works. Now for the working part, what we require is to copy this entire code of the Python, as you can see on my screen, and open up the terminal of the Raspberry Pi via internet. Here we have to create a new file, as you can see on my screen. .py is the extension, and here paste the entire code, and after that we have to save it, and this is the command for running the code, as you can see on my screen. And here you go. As you can see, we have the infrared, red, green, blue, and ambient light luminance. And as I send the command again and again, you can see the changes there, but they are very minute because there is no specific change regarding the intensity of light falling on the sensor. But when I place some object over the sensor, you can see that change, or rather decrease, in the values for luminance, for infrared, RGB, and ambient light. Now instead, when I bring a light source near the sensor, you can see the increase and change in the infrared, RGB, and ambient light luminance. And when I move the light source too near to the sensor, you can see a large increase. So this is how the sensor responds and works. Now what do we require is to have a look over the features and the applications of the color sensor, that is TCS34903. The TCS34903 device provides color and IR light sensing. The color sensing provides for improved accuracy, lux, and color temperature measurements typically used to adjust the backlight intensity and correct the display color gamut. Additionally, it can be used for light source type detection, as it reports the IR content of the light. The applications include ambient light sensing, color temperature sensing, industrial process control, and medical diagnostics. Now this sensor is available and can be purchased from the website that is called controleverything.com, and you can get the code from the source tab from this website. After that, you can download the code as a zip file from this very site. Also, you can have the opportunity to download the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make any clarification if you have, and for further queries you can contact us on, reach us on controleverything.com, and for comments you can post your comments on community page. For articles and blogs you can have a look upon instructables.com, and to subscribe more video tutorials like this you can go to our YouTube channel. I hope you enjoyed this video and have a good one yourself. Thanks a lot for watching.